All right, greetings. Here we go. Quadratic inequalities. You have seen inequalities before. What I'm about to write down is not a quadratic inequality. This is a regular old linear inequality. The difference, that's power of 1. We don't write the little 1 in usually, but anyway, if I asked you to solve this, you could, and then you go, wait, that's 2. I'm going to divide by 2. Then I get x is less than 1. That's the statement I get. Now, in Algebra 1, they showed me that I could draw a number line, and then I could count 1 unit over. I could put a marker there, and then they said, do I color the marker in, or do I leave it open based on the inequality symbol? And since this symbol does not have a line underneath it, we would leave the circle open. So this would remain an open circle. Then we would say x is everything less than that. So it would be all the information down here, etc. Boom. And that's what they showed me in Algebra 1. That's a great thing. It works. But we're a little more sophisticated now. So we're going to write our answers using interval notation. And that's not too bad. Interval notation. Well, this graph goes negatively forever. The biggest number on the number line is 1. I would then put a parenthesis right there. And this notation says the exact same thing as this notation. Now, what about, wait, let's go back. What if this was like one of these symbols? Well, then we would have colored this in. And then our parenthesis would have been instead a bracket. So just so you know, once you learn how to do interval notation, we use it for many different things. So I'm going to now switch gears and go to quadratic inequalities. And quadratic inequalities can look like this. They could look like this. Let's try something like this. Quadratic inequality, power of 2. Well, since we are hitting this topic for the very first time, I'm going to tell you, none of these problems require you to do anything more than factor. You can factor every single problem that I'm going to show you. In fact, this problem would break down like this. In fact, there's a couple problems in the assignment where they give them to you already factored. If somebody gives you a quadratic that is already factored, they are trying to do you a favor because they know that you can say, what number would make this chunk of the puzzle 0? Well, that would be -3. And what chunk of the would make this 0? 6. So if I look at a number line, I could say, here's 0. 6, 1, 2, 3, 4, 5, 6 lives over here. I'm going to put a circle there. Do you think I'm about to color that circle in, yes or no? Yes, I am. Because it has the potential to be equal to it. Not just greater than, but equal to it. Then over here, 1, 2, 3, -3, I'm going to do the same thing. I'm going to color in that circle at -3 for the exact same reason. Now, here's the thing, though. This is not a linear inequality. This has 1, 2, 3 chunks of the number line now. See, there's all this stuff that's less than -3. What's up with that information? What's up down there? There's all the information between -3 and 6. What's up with that? And then there's all the information that's greater than 6. I don't know. So what I'm about to show you is called number line analysis. I am going to pick one number from this part of the number line. I always like to work in multiples of 5 because I can do those easy in my head. So I'm going to pick -5. -5 is a number that I would find over here. If I plug -5 in right there, I'll get -5 plus 3. That would give me -2. If I plug -5 in right there, I'd get -5 minus 6. That's -11. Hey, what would I get if I multiplied -2 times -11? I would get 22. In fact, I would get a positive number. Well, guess what? Any positive number is going to be greater than or equal to 0. So what I just showed you is I choose a value from this spot on the number line, and it is okay. It works out. Que bueno. I'm going to keep that answer. Now, I'm going to jump to the middle. Do you see that 0 is between -3 and 6? If I were to go back and once again plug in 0 where I see x, I would end up with 3 times -6. Why? Because the 0 would replace the x, so I'd get 3 times -6. That would be a -18. Well, that's not greater than or equal to 0. What I'm trying to show you is I'm looking for a valid or a true statement. That would not give me a true statement. Over here in zone 3, I'm going to pick the number 10. 10 would be over here on the number line. And once again, what am I doing? I'm replacing this with 10. I'm replacing this with 10. Now, why don't I plug the 10 in here? I could, but I think it's easier to do this. 10 plus 3 is 13. 10 minus 6 is 4. 13 times 4, well, what the heck? That's 52, but I don't even care that it's 52. It's a positive 52. Anything positive is going to be greater than or equal to 0. So this stuff over here checks out, and it is also okay. So how do I tell somebody all the numbers smaller than -3 and all the numbers bigger than 6 are valid answers? Here's how we do it. We look at interval notation. Everything that is less than -3, that's how you say that using interval notation. Everything to the left infinitely from -3 is part of my answer, unified with +6 and everything greater than that. That's everything that's bigger than 6. You put those two worlds together and you get this statement. That is what our answers look like sometimes. Keep on the lookout. You're going to find a pattern involved here. But let's just walk through this process again. If you need to, pause it, rewind that, and look at it again. But I think if we move on and we do a couple back-to-back, you'll get the rhythm. So this next one, I am going to give it to you already factored. This is what it looks like on some of the problems that we're going to practice. So this one right here, that's the problem. So I say to myself, well, this is easy enough. The answer here is 2. The answer here is 5. So I immediately go to my number line. Here's the number 0 on my number line. There's 2 right there. I'm going to leave that open circle. I'm going to leave it open. I'm going to go 3, 4, 5. There's the number 5 on my number line. I'm going to leave that open circle also. It's because it has no potential to be equal to. Once again, take a look at what I've got. I've got every number below 2. Every number below 2, that's one region of my number line. The numbers between 2 and 5, that's a second region. And then 3 regions. So I'm going to pick a number that is over here on this side of 2. I'm going to pick a number that's over here. Well, 0's over here. Okay, let's plug it in. Wherever I see an X, I'm going to put a 0. Well, if I did that, guess what I would get? I would get 0 minus 2. That's -2. And then I'd get 0 minus 5. That's negative 5. What's negative 2 times negative 5? It's positive 10. Well, if it's positive, it's not going to be less than 0. So this information this time is not valid. It's not good stuff. In fact, I want to jump ahead to the pattern because I don't want to leave you hanging. Over here, pick a number in this area over here. What the heck? I'm going to pick something in this area, which is any number bigger than 5. I like multiples of 5, so I'm going to pick 10. If I put 10 here, I'm going to get 10 minus 2, that's 8. 10 minus 5, that's 5. What is 8 times 5? Well, that would be 40. Once again, that's a positive 40. Anything that's positive is not going to be less than less than 0. So pick a number between here. Either 3 or 4 would be the easiest number. I'm going to pick 4. Let's go back here. If I put a 4 in for x, it would say 4 minus 2. What would I get? 2. If I put a 4 in for x, what would I get? 4 minus 5, negative 1. 2 times negative 1 is negative 2. Negative 2 is definitely less than 0. What am I doing? I'm doing something called number line analysis. I'm finding where my critical values are. It breaks my number line into 3 chunks, and then I figure out which chunk or chunks produce a true statement. This time, the region between 2 and 5 was the correct region. How do I tell somebody that? I say the answer is parenthesis 2, 5, parenthesis. Now keep in mind, that's not a point. I'm not saying the point 2, 5. This is interval notation to let somebody know any number between 2 and 5 will make the original problem true. What if the problem was one of these? Less than or equal. Well, then my answer would have been bracket 2, 5, close it with another bracket. That's how that would have affected that answer, just so you know. Now, I got one more, and then we're going to discuss this pattern, because I don't have to go super into depth on this right now. You'll see it. We'll revisit it. But let's just get the basics down. Sometimes they're nice to us and they give us something that's already factored. Sometimes they're not so nice. They give me something that I have to factor. But rest assured, it will factor. In fact, this one factors up nice and easy. I get 2 critical values. Now, we call these solutions to an equation, but when we're doing inequalities, we call them critical values. That's what we call them. So anyway, why are they called critical values? Well, because they're part of the number line. There's 1, 2, 3, 4, 5, 6. That's really sloppy, but there's negative 6. I'm going to put a circle here. I'm going to put a circle here, right? They're critical values on the number line. So here we go. Do I color those circles in, yes or no? Do I color those circles in, yes or no? And the answer is yes, I do, because they have the potential to be equal to. Once again, you'll see that I have everything smaller than negative 6. I have everything between negative 6 and 1. And I have everything bigger than 1. I have 3 different zones to check. It always comes down to 3 zones. For right now, it does. So here we go. I could pick any number that's in this zone. Is negative 10 a number from the pink area? Sure it is. It's less than negative 6. I could plug it in here. I totally could. But I haven't been doing that on any of my examples. The reason why I haven't plugged it in there is it's easier to plug it in right here. What's negative 10 plus 6? It's negative 4. What's negative 10 minus 1. That's negative 11. So what's negative 4 times negative 11? It's positive 44. The key word there, it's positive. Positive stuff is never going to be less than or equal to 0. It's not. So this stuff, once again, is not working for me. If I pick a number over here, what the heck? Let's pick positive 10. I'm going to plug it in. If I plug 10, positive 10 in here, I'll get 10 plus 6, 16. If I plug 10 in here, I'm going to get 10 minus 1, that's 9. 16 times 9 is a positive number. A positive times a positive is a positive. That's not going to help me in this situation. See, I want my answers to be negative if they're less than or equal to 0. So when we do number line analysis, I want you to notice that there is a pattern going on. Let's scroll up to the first one. In the first problem, the inequality symbol is pointing away from my variables. It's pointing away from my variables. When that happens, when it points away from my variables, I call that an outie. There's going to be two sets of okay answers. They're on the outside. Now check out this last one. It's pointing toward the variables. It's pointing in. I call this an innie. And just like a belly button, it's an innie. The answer is the stuff in between the two endpoints. So down here, I already did a little bit of number line analysis. I eliminated these. So I could pick 0. 0's in the green zone. I would end up with 0 going in here. What's 0 plus 6? 6. What's 0 minus 1? Minus 1. The answer would be negative 6 if I plugged it in. I'm sorry, wait a minute. Yeah. And that is less than or equal to 0. So what I'm trying to say is this. If you do number line analysis on a quadratic inequality, all you have to know is which way the sign is pointing, and you have the answer. This is pointing in toward the variables, so it's an innie. That means the inside between the 2 points is going to be your answer. That's what an innie looks like. What does the outie look like? It's got the U in it. Let's do an outie. Okay, we're going to do another problem, but this time it's going to be an outie. But here we go. I'm going to wrap this up pretty quick. Here's my example. It looks like this. 19x plus 35 is greater than negative 2x squared. Now here's the problem with this. You know there's some rule about adding and multiplying and dividing inequalities by negatives. It causes the sign to change direction. But I'm just telling you, I'm going to move this to the other side. I'm going to add 2x to this side. If I do that, I'm going to have this statement. This stuff is now all on the left, greater than 0. See, when I say there's a pattern to this, there's one exception you have to pay attention to. All the stuff has to be on the left, and the highest powered thing has to be, you guessed it, positive for it to be an innie or an outie, So if the highest powered thing is not positive, you have to be more cautious. Here we go. I'm just going to tell you, this thing factors. If you want, and I'm just going to do it real quick. If you factor this, you will get this answer. The critical value here is easy. The critical value is negative 7. Here, you have to set it equal to 0 in your mind, but if you do that, it's not hard. You can still get the answer and say, oh, negative 2.5 or negative 5/2. That's what this guy is. I'm going to write it like a mixed number. The only reason I'm writing it like a mixed number is it's easier to put on a number line. But I don't even need to put it on a number line. Check this out. Here's 0. 1, 2.5 would be about right there, right? I would make it a open circle, yeah, at 2.5, negative 2.5. Then I'd continue down the line here to negative 7. I'd put an open circle. Once again, you hopefully know why it's open, not closed. Now, as long as the highest powered thing is positive and everything is on the left, you can tell me right now that this is an outie. This one is pointing outward from the variables. Could you break up the number line and do all the analysis information for me? Yes, you could. But what I'm trying to say is, if everything is in the right spot, you have the answer given to you right away. So the answer would be everything smaller than negative 7, parenthesis, unified with, parenthesis, negative 2.5, and everything that is larger than that. Now, should you want to verify that you are correct, you can break this into 3, whoop, I tried to change color there and I didn't, whoops. You can break it into, let's try this again, 3 separate regions like we did on the other ones. You can pick a number from the first region and try it, second region, third region. But what I'm trying to get at is, in mathematics, we love it when we see a pattern. So what do? We go for the pattern. Now, there's one exception that you're going to run into, and it's not really an exception, they're trying to trick you in the book. When you hit a problem, you're going to hit a problem like this. It looks like this. Okay, that's the question they're going to ask you. And you might say to yourself, oh, nice. Since they already broke it down for me, since they factored it, 0 is one of my critical values. And if I set this piece equal to 0 here, when does this equal 0? Well, I could take away 11. I could say negative 3x equals negative 11. I could do, 11 thirds. 11 over 3, that's the other critical value. Now, 11 over 3 on a number line, where does that live? It lives at, what, 3 2/3, right? That's the same thing as 3 2/3. And since I'm going to be counting, it makes it easier. There's 0. Open circle. 1, 2, 3 2/3, right? Open circle. But if you followed my pattern that I just talked about, this would be an any. This would be an any, but it's not. If you pick a number from this location and plug it in, it's going to work. If you pick a number from this location and plug it in, it will also give you a true statement. If you pick anything in this area, it's going to be invalid. It will be incorrect. Let me prove it to you. I'm going to pick the number 2. It's in that zone. So if I put it here, I'd have 2 times, well, 11 minus 3 times 2, that's 11 take away 6. So I get 2 times 5, that's 10. Positive 10 is not less than 0. This stuff doesn't work, but you told me it's an any. It's pointing in towards the variables. Yeah, but guess what? If you were to go like this, you'd have 11x minus 3x squared less than 0. Guess what? The highest powered thing is negative. When the highest powered thing is negative, it's the opposite of what I just told you. So what does that mean? It means be very cautious, do the problem by making everything on one side, and if you get a negative on the high power, just remember, it's probably best to plug in values from the 1, 2, 3 regions and double check and verify that you are definitely doing it correct. Because this answer turns out to be negative infinity to 0, parenthesis, u, then boot, and then 3 2/3, positive infinity. This would be the correct answer. Just one last thing, because I don't want to make you watch more than this. I think you got the picture. But if this was like this originally, how would it change my answer? It wouldn't affect the fact that that stuff's valid. No, that would still be valid. It wouldn't make this stuff invalid. It would still be valid. This stuff in the middle would still not work. But the difference would have been these would have been colored in, and these would have been brackets then. So when you solve a quadratic inequality, remember, right here at the beginning of the process tells you whether you're going to need a parenthesis or a bracket. And just in case you forgot from the first unit test, Mom always said, you don't put brackets on infinity. So those would always be parentheses there. Okay. If you need extra help on this, you can come in at tutorial. You could ask for help in the math lab. You can, come up to me and say, am I doing this right? You could also come up and check your answers because these came from the Green Book. You could look up the odd answers in the back of the Green Book, or you could look up all the answers in my book, which is up front on my desk. But I'm just going to tell you, I hope that this made sense. This is the only thing like it that we've done, but these are quadratic inequalities. So the assignment is on Canvas. It is. It's from the Green Book, and you'll see the page is photographed there in Canvas, all right? So it's from the Green Book, photograph in Canvas. All right, and this has been Quadratic Inequalities. Thank you. Bye-bye.